Hello, thank you for joining. In this presentation, we'll introduce zinc flake technology as an advanced alternative to traditional zinc dust systems for industrial corrosion protection coatings. We will look at the technical principles behind galvanic protection, compare zinc dust and zinc flake performance, and review the sustainability and application advantages that modern zinc flake pigments marketed by Eckhart under the ProFlake brand can offer. Corrosion protection remains one of the most critical challenges across many industrial sectors. Applications such as bridges, offshore structures, pipelines, agricultural equipment, and heavy construction machinery all require coatings that provide long-term durability under harsh environmental conditions. Traditionally, zinc-rich primers based on zinc dust have been the industry standard. While a proven concept, it has, however, some technical drawbacks such as brittle coatings and rough surfaces that call for alternative solutions. Furthermore, increasing demands for sustainability, improved processing, and reduced material consumption are driving interest in such alternative technologies. One of the most promising alternative solutions is zinc flake technology, which can provide equivalent or improved corrosion protection while significantly reducing zinc content. The traditional zinc-rich primers are defined by ISO 12944 and AMP Paint 20 to guarantee proper application and film build. According to these standards, zinc-rich primers contain more than 80% zinc by weight. The zinc particles are generally spherical or irregular in shape, with an average particle size of around 3 microns. The purpose of this very high zinc loading is to create electrical conductivity throughout the coating. Because spherical particles only touch at relatively small contact points, a very high pigment concentration is required to establish an effective conductive network. This high zinc content delivers galvanic protection, but it also introduces formulation and application limitations. To understand the difference between zinc dust and zinc flake systems, it is important to briefly review the principle of galvanic corrosion protection. Zinc is more electrochemically active than steel. This means zinc will corrode preferentially, sacrificing itself to protect the steel substrate beneath. For this sacrificial protection to work, there must be an electrically conductive pathway connecting the zinc particles to each other and ultimately to the steel surface. This interconnected conductive structure is known as the percolation network. Without sufficient particle-to-particle contact, the so-called percolation threshold, galvanic protection cannot occur effectively. One of the most important factors influencing the percolation threshold is particle geometry. Traditional zinc dust particles are spherical or irregular and pack randomly within the coating film. Their relatively low surface area means that high concentrations are necessary to achieve conductivity. In contrast, zinc flakes have a platelet-shaped structure with a very large surface area. During application, these flakes tend to orient themselves parallel to the substrate. This orientation creates significantly larger contact areas between particles, allowing conductive pathways to form much more efficiently. As a result, zinc flake systems achieve galvanic protection at much lower pigment loading levels. This slide compares the physical characteristics of zinc dust and zinc flakes. While zinc dust particles are small and roughly spherical, zinc flakes have extremely high aspect ratios, approximately 40:1. Although the flakes are larger in diameter, they are extremely thin, typically only 4 microns. This platelet structure dramatically increases the available surface area and creates more efficient conductive pathways within the coating. The key implication is that zinc flakes can provide corrosion protection with substantially lower zinc consumption. The difference in percolation threshold directly impacts required pigment loading. Conventional zinc dust systems typically require more than 80% zinc content to establish sufficient conductivity. Zinc flake systems, however, can achieve effective galvanic protection at approximately 25% zinc loading. This reduction is possible because the high aspect ratio flakes create much larger particle contact areas. Lower zinc loading provides several important advantages, including reduced raw material consumption, improved formulation flexibility, better overall technical properties, and enhanced coating performance. One of the major advantages of zinc flake technology is that it combines two corrosion protection mechanisms within a single coating. First, zinc flakes provide galvanic protection through electrical conductivity and sacrificial corrosion, the same cathodic protection principle used in traditional zinc-rich primers. Second, the platelet structure creates a lamellar barrier effect. The aligned flakes form overlapping layers that slow the diffusion of water, oxygen, and corrosive ions through the coating. This combination of active and passive protection results in enhanced corrosion resistance compared to conventional zinc dust systems. Because zinc flake systems require significantly lower metallic zinc content, formulators gain much greater flexibility. Zinc flake coatings can be tinted, or particular additives can be added to improve special film properties. Higher binder content improves coating flexibility and reduces brittleness. In addition, rheological behavior improves considerably, enabling easier application, better film formation, and more consistent coating thickness. The smoother surface appearance can in some cases eliminate the need for intermediate coats, simplifying the coating system. Overall, zinc flake technology enables coatings that are both technically robust and easier to process. One practical challenge with traditional zinc-rich primers is sedimentation. Zinc dust has a high density of approximately 7.1 grams per cubic centimeter, which causes strong settling during storage and transport. This can lead to hard sediment formation and difficult redispersion before application. Because zinc flake systems use substantially lower zinc concentrations and suspension stability is greatly improved. This results in easier handling, improved storage stability, and simpler mixing. The formulation advantages of zinc flakes also translate into improved application performance. Spray application becomes smoother with reduced sagging and fewer nozzle blockages. Rheological control is more consistent, helping achieve uniform coating thickness across large surfaces. Improved formulation stability also reduces production interruptions and minimizes rework in industrial coating operations. An additional commercial benefit is that zinc flake systems can sometimes enable two-layer systems instead of traditional three-layer systems, reducing both labor and application costs. Sustainability is becoming increasingly important in the coatings industry, and zinc flake technology offers several clear environmental advantages. Traditional zinc-rich primers often contain around 80% metallic zinc, whereas zinc flake systems can reduce this to approximately 25%. This significantly lowers raw material consumption and reduces the environmental footprint associated with zinc mining, processing, and transportation. Additionally, lower zinc concentrations help reduce metal emissions during maintenance and surface preparation activities. The reduction in zinc content also has a measurable impact on carbon footprint. As shown here, traditional zinc dust coatings can generate approximately 36.5 kilograms of CO2 equivalent per kilogram of coating. By comparison, zinc flake systems reduce this value to approximately 20.4 kilograms. For manufacturers seeking to reduce Scope 3 emissions and improve sustainability metrics, this can be a significant advantage. Lower zinc concentrations also contribute to reduced metal emissions during maintenance and fabrication operations. During welding, zinc flake coatings generate significantly lower zinc concentrations in welding fumes compared to traditional zinc-rich primers. During sandblasting and surface preparation, less zinc particulate matter is released into the environment. These reductions contribute to improved occupational safety, reduced soil contamination, and easier compliance with environmental regulations. Eckhart offers a broad ProFlake portfolio designed to address different corrosion protection requirements. Fine grades such as ProFlake Zinc 1400 provide very high surface area, while balanced grades such as Zinc 2000 are optimized for heavy-duty corrosion protection. Coarser grades such as Zinc 3000 are suitable for high dry film thickness systems. The portfolio also includes paste-to-products optimized for solvent-borne systems, as well as specialty grades such as Standard Zinc Matte Black for decorative and protective applications. This range allows formulators to tailor coating performance to specific industrial requirements. In addition to solvent-borne systems, Eckhart has also developed zinc flake technology for modern waterborne coatings. ProFlake Zinc Hydro PM 3090 is a stabilized zinc flake paste specifically designed for waterborne epoxy systems, the first of its kind. The product offers excellent gassing stability, maintaining performance for 8 hours in the systems tested in-house, while also demonstrating compatibility with 2-component waterborne epoxy formulations and corrosion resistance exceeding 1,500 hours in salt spray testing. This development supports the ongoing industry transition toward lower VOC and more sustainable coating technologies. Zinc flake technology is suitable for a wide range of industrial applications. These include tanks, pipelines, containers, automotive components, industrial machinery, and transportation equipment. The technology is particularly well suited for ACE applications, agricultural, construction, and earth-moving equipment, where coatings must withstand severe environmental and mechanical stress. The combination of corrosion protection, flexibility, and improved application properties makes zinc flakes highly versatile across many industries. To summarize, ProFlake zinc flake pigments provide a modern and highly efficient alternative to conventional zinc dust systems. They combine galvanic protection with a barrier effect, enabling excellent corrosion resistance at significantly lower zinc loading levels. This leads to improved flexibility, better application behavior, lower carbon footprint, and enhanced sustainability. In addition, zinc flake technology supports both solvent-borne and water-borne coating systems, offering formulators broad compatibility and future-oriented solutions. Thank you very much for your attention. If you would like additional technical information, formulation support, or product samples, please visit our website at eckhart.net.